Okay, so last section we're going to look at this week is 2.1. We're going to split it into two parts. There's really a third part to it, but we're not going to do the third part because we didn't have class on Monday. So the first part of section 2.1 basically talks about how we measure an angle. What's an angle and how you measure it. Most people are probably familiar with degrees, but there's another unit that you can use. Does anybody know the other way you can measure an angle besides degrees? Yeah?
Sine, cosine, and tangent.
So sine, cosine, and tangent are functions. We're not going to use those this week, but we'll see those next week. So those are functions. It's like you take a number and you plug it into it. It's like square root. Take a number, plug it in, and you get an answer. But does anyone know the other way besides degrees? How you can measure an angle? Okay, so we'll take a look at what that is. And then tomorrow, that new way we're going to learn to measure an angle, we have to use that to do the formulas from tomorrow. Okay, so that's where we're going. Right, so before we can measure an angle, we're just going to start out by defining what an angle is by describing the two parts that it's made up of. So when we're talking about an angle, usually we're talking about the sides of it, and those are called rays. So a ray is basically a line segment that continues forever in one direction. Okay, not a line, because that goes forever in both directions. It has a starting point and continues in one direction forever. Where the ray starts, that's called your vertex. And I just said that. Okay, so here, that's how we usually draw a ray. Now, if we take another ray and make it so that the starting points are the same, now you just made an angle. Okay? And that's the next part. So if you take two rays, put them together with a common vertex, just like I did up above, now you've created an angle. And there's another example of the same thing I just did. A ray, another ray, give them a common vertex, now you just created an angle. So when you draw an angle all by itself, that's how we usually do it. Two rays. Now, technically, if I did something like this, and there's three of them there, but the one I circled, that's still technically an angle too. Even though this thing in red and that thing in blue, those aren't rays anymore. What are those called? Legs, which are, you think like in geometry, like if you just take this, what's that? Just all by itself. It's a line segment. So when we draw shapes, right, polygons, an angle can be made up of two line segments. When you draw an angle all by itself, it's usually rays. That's how we usually do it. Okay? But both examples of angles. So angles have two sides. They have an initial side and a terminal side. In that picture, that's the initial. That's the terminal. Here's another picture, initial, terminal. So how do you figure out which side is initial and which side is terminal? Well, in a minute, we're going to draw the initial side a certain way all the time. So that way there's no question. But if you rotate inside the angle, okay, this is inside. If you're inside the angle and you rotate counterclockwise, the side you start at is the initial, and the side you end at is the terminal. Right. So if I had something like this, right, and let me just do a different color. Which side would be the initial there? The red or the black?
The red.
Yeah, the red side would be your initial. As you rotate inside the angle, counterclockwise, the side you start at is the initial. Side you end at is the terminal. Now, the angle on the left is drawn better than the one on the right. Okay, that's how you usually want to do the initial side. Okay, but I'm gonna mention that later on. There's nothing wrong with the one on the right, but it's not drawn in what we call the standard way. Okay, the one on the left is. So when we talk about measuring an angle, okay, at first most people use degrees. Okay, that's the simplest way. Most people are kind of familiar and can kind of visualize, like if I said, okay, visualize 90 degrees. You know, people think about a right angle, like capital L, right? So you're familiar with it. Well, there's two different directions you can measure angles in, clockwise and counterclockwise. And I'm going to show you a picture of something real quick. Okay, so let's take a look at what happens when we measure an angle either in the clockwise or counterclockwise direction. So this program, what it does is it lets me drag this red circle anywhere that I want on the perimeter, and it'll make an angle. And it's going to show me what the angle is right down here, okay, in degrees or in the other unit, which I'll tell you what it's called later. Does anyone have a guess what the difference in the number is going to be, whether I go clockwise or counterclockwise? How that number that's highlighted would change? If you go counterclockwise, it'll be this kind of number, and if you go clockwise, it'll be this kind of number. Yeah.
If you go clockwise, it'll be down from 360. If you go counterclockwise, it'll be up from 0.
Yeah, so it's going to have to do with positive and negative. Okay. If I go counterclockwise, notice I can only move one of the rays of the angle. The other one stays right where it is. But going in this direction, I get positive angles until I go all the way around. Now I'm at 360, and I can keep going. Right? So that's more than one revolution. Now if I go the other way, it's measuring in a clockwise direction. Right? There was a little arrow on the end of that red arc that would kind of be helpful so you could see it. But as I go this way, now I'm getting into negative angles. So that's the only difference between whether you measure an angle clockwise or counterclockwise. Okay? Usually, we like to stick with positive if we were given a choice of using positive or negative. Okay, so if your rotation from initial to terminal side is counterclockwise, positive. If you go clockwise, that's a negative angle. So what we're going to do is we're going to make the initial side very easy to figure out which side it is. Right? So if you're confused at all, how do you figure out which side is initial and terminal? We're always going to put the initial side in a certain spot. And this program that I just had on the screen does exactly what we're going to do. The initial side is always going to be on the positive x-axis. The terminal side, well, that can be anywhere. It can be over here, down there. All right? But the initial side is never going to move. Okay. And drawing it that way is called drawing the angle in standard position. Technically, for an angle to be in standard position, there's two things. Two things that have to happen. I just told you one of them. The initial side is on the positive x-axis, but the vertex of the angle is also at the origin. All right. If you look back at this program, the vertex of this angle is always at the origin, never moves. Be nice if I could zoom back out. And the initial side is always on the x-axis. Okay, well, we'll try that later. So that's another example of an angle in standard position. How about, yeah.
If you rotate counterclockwise, the first one to hit the x-axis is the initial. Sure.
Yeah, if you go counterclockwise, like in this case, the one in black is initial,
Yeah.
the one in red is terminal.
So if the one in black wasn't on the x-axis,
Okay, let's, I should have kept it black, but let's just go like this. All right, so now it's not on the x-axis. Is that standard position?
yeah.
How come that's not standard position? Some people are saying no.
Because the initial is not on x-axis.
The initial side is no longer on the positive x-axis. The vertex is at the origin, that's fine. But there has to be both. The vertex has to be at the origin, and the initial side has to be on the positive x-axis. So what if I did this? Initial side is now on the positive x-axis. Is that standard position? No, what's wrong with that?
It's not on the origin.
The vertex isn't at the origin. It's got to be both. So what standard position does is if I said to you, all right, I want everyone to draw a 45-degree angle, everybody's would look pretty much the same. Right? It's not like some people would have it twisted or turned, as long as I say to draw it in standard position. Okay? Everyone would have the initial side on the positive x-axis, and then the terminal side, halfway between the x and the y-axis for our 45. Okay. Okay. Any question on that? Just kind of some background stuff with angles. So, degrees is one way to measure an angle, and now I'm going to show you a little bit about the other way. Okay, so as I was using this program, you probably saw, like right now, it says -90, little circle up by the 0. That's degrees. Well, this one down here is radians. And you might notice that sometimes it writes it as a fraction. Like sometimes it writes it as a decimal. So if I go up to like 22.5 degrees, it says pi over 8. If I go to 45, it says pi over 4. If I go up to 90, it says pi over 2. And if I go a little bit off 90, it changes it back to a decimal. So maybe that tells you a little bit about what radians has to do with it. It has to do with pi. Right? So pi comes up a lot with this. So we want to figure out, the main goal of this part is how do you change degrees to radians and radians to degrees. That's what I want you to be able to do. Let's start with something a little simpler, okay, just to kind of get the concept. Degrees to revolutions. If you had to change between degrees and revolutions, anyone tell me how you would do that? You have to know something to start with. Does anybody know anything about degrees and revolutions? Kind of need a connection between the two. Yeah.
360 degrees is one revolution.
Yeah. 360 degrees is one revolution. Now, if you said, well, how about 800 degrees? How many revolutions? Well, Starting here, this is a fact that I was given that we know is true. Okay? 800 degrees. And now you could just put x revolutions and solve it. But the key is that you started with something that was already true. Right? That's how we're going to have to convert between degrees and radians. We have to have a fact that we know there's this many degrees in this many radians. Just like there's this many degrees in this many revolutions. Now, was it Alex? Did you tell me that? How did you know that?
Just math is my shop related.
So you just know it. You just know it from something. It's kind of the same thing with degrees to radians. You just have to know it. From what? From something. You just have to be taught there's this many degrees and this many radians, and then you're good. Right? Now, if he had said to me, there's 720 degrees in 2 revolutions, is that the same fact?
Yes.
Yeah, it's just not reduced. So there's an unlimited number of facts he could have given me. Okay? Could have said in 10 revolutions, there's 3,600 degrees. The point is, I just need a fact, something, a connection between the 2 units that I want to convert between. So we know that in 1 revolution, there's 360 degrees. We want to figure out the question mark. What is the connection between degrees and radians? How many degrees in how many radians? So we're going to figure out how many radians are in 360 degrees. Why? Because 360 is a full circle. It's easy to work with. Could we do how many radians in 180 degrees? Sure. You need something, that's all. So first thing I'm going to do is I'm going to describe what a radian is to you using more of like geometry. If you look at the word radian, does it kind of look like any other word from geometry? Yeah, trying to learn some names. Andrew?
Radius.
Radius, yes. And the definition of a radian has something to do with a radius, right, in a circle. So we're going to start just by drawing that circle. So what I've drawn is an angle with the vertex. I tried to make it look like it's at the center of the circle. And the 2 rays of the angle come out from the vertex and they hit the circumference of the circle. They hit the perimeter. They hit it here and here. And then what I've done is I've drawn an arc in red between those 2 points. R stands for the length of each side of the angle, the terminal and the initial side. And since the vertex is right at the center of the circle, any line drawn from the center to the edge of the circle, that's the definition of the radius. So, if the length of that arc in red came out exactly the same as the length of the radius. So if you took, it's an arc, so it's kind of hard to use a ruler to measure it, but if you took like a piece of string, okay, and you put it on that arc in red, laid it right on top of it exactly, and then brought it over to a ruler and straightened it out and measured how long it was. And then you took a ruler and you measured the length of the radius. If the arc in red and the radius in black came out exactly the same, then you have just drawn a picture that is 1 radian. Now it doesn't help us to convert between degrees and radians. What that does is it kind of gives us a visual of what a radian would look like. The size of this arc would be the same as the size of this radius. Now, if you had a circle and you did something like that, look at the arc in red now. Is the arc in red, do you think it's smaller than the radius now or bigger? It's smaller. So this angle is smaller than 1 radian. How much smaller? I don't know. It's smaller. Okay, do the same thing. Draw a circle. Draw an angle like that. Here's my arc. Now if you were to measure the arc in red and the radius in that circle, do you think the arc is bigger or smaller? It's bigger. So now you've drawn a picture of an angle that is bigger than 1 radian. Okay? This angle right here, bigger than 1 radian. All right. Make the arc exactly the same as the radius, exactly 1 radian. We're going to need that fact tomorrow. Okay. Kind of gives us a special relationship between the size of an arc and the size of a radius, okay, in a circle. All right. So in order to help you now figure out how do we convert between degrees and radians, I've got to give you something. Okay, you gotta start with some kind of fact. So this is the fact I'm going to start you off with. It says that if you measure an angle in radians, I'll just read it exactly. An angle's measurement in radians is numerically equal to the length of the corresponding arc of a unit circle. So before I can describe the whole sentence, let's just define that word, a unit circle. A unit circle is just a circle with a radius of 1. That's all a unit circle is. Circle with radius 1. All right, so now let's see if we can make sense of what that says. So this says that if you measure an angle in radians, okay, that's the first part. If you measure an angle in radians, it comes out the same as the length of the arc. Okay. So here's a picture. Let's say that that's a unit circle. Okay. Radius of 1 what? 1 foot, 1 inch, it doesn't matter, just 1 unit. Okay. Here's my radius. Let's just call it 1 foot. So you've got that. Let's draw our terminal side over here. Let's say that you knew how to use it. Let's say you had a protractor that measured in radians. Most protractors measure in degrees, okay? But let's say you had one that measured in radians. And you take your protractor and you measure that angle in radians right there. And you write that number down. Then you take a piece of string and you put the piece of string on top of that arc. Right? Then you bring it over to a ruler and you measure it and you see what you get. The length of this arc measured by your ruler and the length of that angle measured by your protractor would be exactly the same number. They come out exactly the same. That doesn't happen on every circle. That only happens on this kind of circle, a unit circle. Right? And if I actually had a protractor, like I could try it and I could show you. I could actually draw something to scale, make a circle that's exactly 1 foot or 2 foot diameter. I don't really have something to draw all that. But that's the idea. If you measure an angle in radians, and then you measure the arc on the circle, the size of the arc and the size of the angle are always the same on a unit circle. Right? So what that means is if we can figure out how big the arc is that goes all the way around the circle. Okay? When it's an arc that goes all the way around the circle, we usually don't even call it an arc anymore. Now you call it a circumference. But technically, circumference is an arc. Okay? If you can figure out the size of this arc that goes all the way around the circle, the length of the arc is the same as the size of the angle that goes all the way around the circle. So if you can tell me the size of the arc that goes around the circle, then you know how many radians it takes to go all the way around, because they're exactly the same. Right? So let's see if we can figure out the size of this arc. Does anyone know a formula from geometry that helps you to figure out the size of an arc that goes all the way around a circle? What do we call that again if it's an arc that goes all the way around a circle? Circumference. So I need a formula that involves circumference. What's the formula for circumference of a circle? Yeah?
Pi r squared.
That's area. So important one that we might use tomorrow, but not the one we need right now. That's still a good formula. But it does have pi in it, the one we're looking for. Anyone else? Think they can tell me the formula for circumference of a circle? All right. So anyone take a shot at it? Take a guess what they think circumference. I mean, it's got pi in it, so there's only like 2 other things you need to know. Yeah.
Isn't it like the radius times pi divided by a half or something like that?
Close. You're kind of mixing 2 things, but we're on the right track. Alex?
Did somebody do diameter?
You could say it with diameter, or you could say it with radius. It depends if you're going to use the 1/2 or not. I would just do radius. Yeah.
2 pi r.
2 pi r. Yeah. So circumference equals 2 pi r. All right. Now look back at what we said. The circumference, which is just an arc, is the same as the angle in radians. So if you can tell me the length of the circumference of a unit circle, the length of the the size of the circumference is the same as the angle in radians. So if you can say the length of the arc that goes all the way around the circle, then you know how many radians to go all the way around the circle. Same number. So what would I fill in if I'm doing this on a unit circle to figure out the size of the circumference? What would I fill in?
The radius?
Yeah, what would you fill in for the radius? Yeah, on a unit circle, the radius is 1. What's 2 pi times 1?
2 pi.
Just 2 pi. 2 pi feet, 2 pi inches, doesn't matter. But the circumference is 2 pi. Now we know the length of the arc in a unit circle. It's 2 pi. The length of that arc is the same as what?
So that's for everything.
Yeah, that's for every unit circle.
Every
Yep.
unit circle, the arc is.
The arc is always 2 pi. Yep, always. So the arc is 2 pi, and what did we just say that the arc is the same as? Yeah?
The radius.
The radians. So if it takes 2 pi units to go all the way around a circle, that's the circumference, how many radians to go all the way around the circle?
2 pi.
2 pi. It's the same. So now we know that to go all the way around the circle, it is 2 pi radians. So we just made a connection between degrees and radians. There are 360 degrees in 2 pi radians. So let's write that down. There are 360 degrees in 2 pi radians. We could reduce that fact a little bit. That's kind of like saying there's 720 degrees in 2 revolutions. You can make it a little smaller. Can anybody reduce both sides of that for me and give me a little bit smaller numbers? Yeah?
It used to be 180 equals pi.
Yeah, 180 degrees equals pi radians. Okay. Now, that's better because the numbers are a little smaller. But usually when you give someone a conversion between 2 things, it has a certain number in it all the time. Anthony, can you tell me a conversion involving time? Any unit to any unit you want.
Like seconds to minutes?
minute.
Sure, how do I do that?
Well, there's 60 seconds in a minute.
60 seconds in how many minutes? 1 minute. Can someone give me another conversion? It could be anything. Length, time, just how do I convert something else to something else? 12 inches equals 1 foot. Now I didn't tell you guys what to tell me. I just said give me a conversion. Both of you gave me a conversion that had the same number in it. What number? 1. Usually when you give someone a conversion, a 1 is the easiest way to say it. I mean, you could have said in 3 feet there's 36 inches. You didn't. You said in 1 foot there's 12 inches. You said in 1 minute there's 60 seconds. Right? 1 is usually a good number to give someone with a conversion. So let's do the same thing here. Okay. I'm going to take this fact and we're going to get a 1 in it. Which side we decide to make a 1 is going to control whether we're converting from degrees to radians or radians to degrees. All right. So let's do it. How do I want to do it first? All right. Let's get a 1 on this side. To get a 1 on the left, what would I have to divide both sides by?
180.
180. So let's do that. I'm just going to copy it over down here. Divide by 180. Divide by 180. Notice just 180. 180 divided by 180 cancels out, and you're left with 1 degree. The degree symbol is still there. Equals pi over 180 radians. Now we've got a formula that has a 1 in it. Let's say I wanted to know how many radians in 2 degrees. What could I multiply each side of that equation by? Yeah. Let's put a box here. Let's put a box here. If you put a 2 here and a 2 here, now you've got a formula for 2 degrees. In 2 degrees equals 2 pi over 180 radians. How about if I wanted to know in 5 degrees? How many radians in 5 degrees? What would I do? Times both sides by 5. If you times the left by 5, now you have a formula that says 5 degrees equals times the right by 5. 5 pi over 180. The key is this right here. No matter what amount of degrees you want to convert to radians, you always take the degrees, multiply by pi, because pi is in the top, and divide by 180. Those are the 2 steps. Times pi divided by 180. What times pi? Whatever you want to convert. 5 times pi, 2 times pi, 7 times pi, 60 times pi. Whatever number they tell you to convert. You always multiply by pi and then divide by 180. And that's how you convert from degrees to radians every time. Yeah, question?
I was just going to ask about that conversion before we just said degrees.
Yep, this is the conversion to change degrees into radians. Step 1, multiply what you're converting by pi. Step 2, divide by 180 because it's in the bottom of the fraction. Now, when we do it the other way, radians to degrees, you're going to see it's very, very similar. Everyone have those 2 steps? Okay, let's go back to this fact we had. 180 degrees equals pi radians. I'm just going to go back over here. Now what I want to do is get a 1 on the other side. So what could I divide each side of this equation by to get a 1 on the right? Yep, divide by pi. Divide by pi. Divide by pi. So we started with an equation that's true. Everybody agrees that there's 180 degrees in pi radians. We kind of proved that, we went through it. So if you start with something that's true and you divide each side by the same thing, it's still true. It's like just a smaller version of the fact, but it's still true. So pi divided by pi gives me 1. 180 divided by pi, we just leave it like that. So that formula tells you how big 1 radian is. If you wanted to know in degrees how big 1 radian is, it's 180 divided by roughly 3.14. So 1 radian is about 57 degrees, roughly. Now, what if I wanted to know how big 2 radians is? What would I do to each side of this equation? Yeah.
Multiply by 2.
Yeah, if you double each side. I'm just going to put a little box here. I would do times 2. And I could go right here and do times 2. Now I've got an equation that says 1 times 2, or 2 radians, equals, and I got a calculation I could do out. What if I wanted to know how many for 5 radians? I wanted to change 5 radians to degrees. Times by 5. 1 times 5 is 5 radians equals, and now do this calculation out. This is the key right here. Compare it to what we had before. Pi over 180, 180 over pi. It's just the opposite. So if you want to convert radians to degrees, the 2 steps are multiply by 180, divide by pi. Multiply by 180, divide by pi. That's radians to degrees. Now they're both kind of similar. It's like pi over 180 or 180 over pi, so it's kind of easy to mix them up. So I'm going to show you a way that you can remember which one is which without even really having to memorize this. The only thing you have to memorize is when I say degrees, I want you to think of the number 180. Okay, so when I say degrees, think 180. When I say radians, think pi. Just associate those 2 things together. Degrees, 180. Radians, pi. If you can remember that, then these 2 steps and these 2 steps become automatic. You just have to remember 180 degrees, pi radians. Okay, so the last thing we'll do is we'll just practice converting a few numbers between degrees and radians. Okay. So directions say convert to radians. So anytime you're converting between degrees and radians, you're always multiplying by a fraction. You have 2 choices, pi over 180 or 180 over pi. You just have to figure out which one it is here. So if you want, it might help the first time, think of 60 as a fraction. Think of it as 60 over 1. In the future, I probably won't do that. Degrees right now is in the top of the fraction. My goal is radians. I need degrees to cancel out. So where would degrees have to go in the green fraction on the right to cancel out degrees on the left? Okay? It would have to go in the bottom. That means degrees is going to go in the bottom. And the only other place for radians has to be in the top. Now degrees is going to cancel. It's in the top, it's in the bottom. Gone, I crossed it out. Now, you just have to remember, when I said degrees, what number did I say to always think of? Your 180. So 180 goes in the bottom. And when I said radians, you're supposed to think pi. So pi goes in the top. That's how I remember which one goes where. I look at the unit I want to cancel out, put it in the spot it needs to be to cancel, and then whatever, I go from there. Degrees 180, if it was radians, I put the pi next to it. Okay. And now before we multiply, we can reduce. 60 goes into itself once. And how many times does 60 go into 180? 3. So your final answer is 1 times pi, which is pi, over 1 times 3. Pi over 3. And that's how you leave the answer. You don't have to change it to a decimal unless they tell you to. Let's go back here for a second. If I put this, if I can get it on exactly 60 degrees, well, you'll see that it says it's pi over 3. Okay? Notice how they wrote pi over 3. Look at carefully how they wrote it. Look at how I wrote it. What's the difference? Yeah? The word RAD. You normally don't see RAD. On the homework, on tests, you kind of got to get used to seeing your answer like that. For the first time though, I put RAD just to kind of help you think about the units. But we kind of got to get used to the word RAD being invisible. If it's degrees, you got to put the little circle. You have to. Okay, just like they do right there. But if it's radians, you can just leave it blank. Okay? It's kind of like in math when you put a variable, and there's no number in front of it, we assume it's 1. Well, when you're dealing with angles, if you don't label it, we just assume radians. All right, let's try this one. 150 degrees. All right, so Cal, where would degrees go here to cancel out the degrees on the 150? Top or bottom?
The bottom.
Yep, it's going to go in the bottom, which means radians is in the top. I'm not going to write RAD this time. Just pretend it's invisible. RAD in the top. Okay, so that cancels degrees. Matt, when we think degrees, what number do we always connect with degrees?
180.
Yep, nice job. 180 degrees. And Megan, when we think radians, what number goes with that?
Pi.
Pi. Should I put RAD? No, pretend like it's invisible. RAD. Now, it's up to you. You can reduce now or reduce later. I like to reduce first. Right? So 150 and 180. You want to think of a number that goes into both 150 and 180? 3? Yep. You can go even bigger. Yep.
30.
30. Yeah, 5 would work. 30, I think, is the biggest. And Anthony, how many times does 30 go into 150?
5.
180?
6.
6. And that's your answer. 5 times pi over 6. That's it. 5 pi over 6. Any questions on that one? So you might kind of be wondering, well, when are you supposed to change it to a decimal, and when do you leave it as a fraction? Well, first of all, on a test, I will let you know, round at your answer or leave your answer as a fraction with pi. But generally, when you leave your answer as a fraction with pi, is anytime you have a multiple of 30, so that includes 60, or a multiple of 45. So any numbers that are multiples of 30 and 45, that's when you generally leave it as a fraction with pi. Okay. If there were never any directions. So something like 57 degrees, you're just going to write that as a decimal. Right? That's just kind of a random angle. It's not really anything special. Multiples of 30 and 45 are considered special. Right. So why don't you take a second and try that one. You treat it just like the problem was 45 degrees. You don't do it any different. Except when you're done, throw a negative in front of your final answer. Okay, you're going to do it exactly the way we did the top two. Okay, so directions are still the same, changing degrees to radians. Anybody tell me what did they multiply by? Just tell me what goes in the top, what goes in the bottom.
Pi goes in the top.
Yep.
180 degrees goes in the bottom.
Perfect. Pi in the top, pi radians, 180 degrees in the bottom. Okay. 45 and 180. Biggest number that goes into both of them. Yeah.
45.
Yep, 45. Goes in once. How many times does 45 go into 180, Jason?
4.
4. So, Jason, what would your final answer be here?
Negative pi over 4.
Perfect. And reminder, what does that negative tell you about the angle? That it goes which way? This is clockwise. Yep. Versus counterclockwise. Alright, so last one we'll do converting degrees to radians. Is just one where they say round. Okay? So there's no difference here. You don't have to reduce anything. You just put it all into a calculator. Times pi over 180. Just type it all in. 107 times pi divided by 180. Whenever I type it in, I always use the pi button. I'll show you in the next part. If you don't use it, it messes your answer up a little bit. So 107 times pi divided by 180. Okay. You can type it in just like that. It's about 1.87. If you wrote 1.86, I'd probably take a point off because you knew how to convert it, but you didn't round it right. 1.867 rounds up. Okay, 5 or higher. So that's 1.87. Okay, so any questions on changing degrees to radians? Did a few exact, and then I did one with you doing it as a decimal. All right, so last thing, changing the other way. Now, I'll put RAD the first time, just like we did before, but eventually you have to get used to seeing it like that. Okay. But pi over 6 radians. Okay. Same idea. We're going to multiply by a fraction. It's either pi over 180 or 180 over pi. The goal is degrees. You want your radians to disappear. So Abby, if I want radians to disappear and it's in the top of this fraction, where would it go in that fraction?
On the bottom.
On the bottom. So radians on the bottom, degrees on the top. That's going to cause, I'll cancel them out in a minute. Right, and how about Madison, what number do we always put with radians? Pi. And how about with degrees?
180.
Yep, 180. Okay. What cancels out there? The pi's cancel out. What else? The unit itself cancels out. And all you're left with is 180 degrees divided by 6. So what's 180 divided by 6? 30. Yep. Now, do I have to put the little degree symbol?
Yes.
Yeah. If I leave it like that, that's 30 radians. Now it's 30 degrees. And that's it. That's how you change a radian to a degree. All right, let's try this, but this time let's get rid of that. Okay. That's what the problem's going to look like in the homework and on the test. Convert 3 pi over 2 radians to degrees. So if you get stuck, just remember there's an invisible RAD right next to the 3 pi. All right, so Emily, if I want to convert that to degrees, where are my radians going to go to cancel out? Top or bottom?
Bottom.
Bottom. Which, again, I'm not going to write it. What's the number we always put with radians?
Pi.
Pi. And what's going to go in the top?
Degrees.
Yep, and the number?
180.
Yep, perfect. So radians cancels out. That's invisible. Pi cancels out. 2 goes into itself once. 2 goes into 180 90 times. So what am I left with for a final answer here? 90 what? Not over 3 because the 3's in the top. 90 times 3, which is how much? How much? 270. Yeah, 270. Okay, and let's finish up with one where we round. I'm going to skip that one. Let's do this one. And the directions here are convert to 2 decimal places. And it just says 3. Okay, so it's 3 radians. So I think, okay, I want to get rid of radians, goes in the bottom. Anytime you want to get rid of radians, put it in the bottom. Okay, and let's see what we get. So I'm going to do this using the pi button, and then I'll do it using 3.14 and see what happens. So 3 times 180 gives us 540, divided by pi. So that's 171.89 degrees. Okay, and we rounded to 2. So to the second decimal place, we got 0.89. Now, let's do it using 3.14. So 3 times 180, again, would be 540, divided by 3.14. Now, if you got an answer of like 171.88, I mean, that's pretty close. Or if you got 0.90, that's pretty close. 0.97, that threw it off quite a bit. You know, it's not off by just a little. We went from 89 to 97. All right. So that's why make sure you use the pi button, okay? Especially if you're rounding to 2 decimal places properly. It'll mess you up. Right. Okay. Any questions on that? All right. So that's converting between degrees and radians. Okay. So homework tonight is page 99. And it's 36 to 68, just evens. Okay, just the evens. Okay, tomorrow we will finish all the material for the week, section 2.1, part 2, and we will have our first test on Friday. If you don't have the syllabus sheet, make sure you get that in by Friday. And don't forget for the test, you can make a reference sheet if you want. Just regular 8.5 by 11 paper, double-sided is fine. I don't think you'll need both sides, but you can if you want.